Continuing with 4.4, 4.4b, with our unit circles and trig functions. Let's say in this case, we were given a trig function. Let's say we're given the cosine of theta equals negative 0.8, and let's say it lies in the third quadrant, so quadrant 3. So let's think about that. What I would always like to do is I always want to draw a picture. So let me write this again. Cosine of theta equals negative 0.8. Quadrant 3, this is quadrant 3 over here. So it's going to land somewhere down here. This will be our angle per se. Okay, so that we know. So I know 100% sure my x value has to be negative. Well, that makes sense. My cosine's negative. My x value is negative. But I also know that my y value has to be negative. So my sine of theta also has to be negative. Let me rewrite this 0.8 in terms of a fraction, so because that's easier to manage. So 8/10, simplify that to be 4/5. So cosine of theta is actually 4/5, or, well, negative 4/5. So here we have, if I draw a picture of that triangle over here again, and theta is this, in this case here, cosine is my adjacent, so my adjacent is negative 4. My hypotenuse, always positive, is going to be 5. Oh, this is a special triangle. I don't have to do Pythagorean, but if I did Pythagorean, I'd find that this side is 3, or in this case, negative 3, because I'm going down here in the third quadrant. So now I can find the other functions just fine. So my sine of theta, negative 3/5. My cosine already given, so tangent of theta is negative 3/4, negative 3 over negative 4, so that's positive 3/4, 3/4. My cosecant of theta is the inverse, so negative 5/3. Secant of theta is my inverse, negative 5/4, and cotangent of theta is the inverse, which is 4/3. Okay, let's do another example. Let's evaluate our trigonometric functions of a particular angle. So let's say we are given, we want to evaluate cotangent of 0, and this is in radians, or no matter, but still 0 degrees. So if we think about this, 0, that's here, and that point is 1, 0. And they want the cotangent of that. Cotangent, remember tangent is sine over cosine. Cotangent is cosine over sine, or in this case, our x over our y. Our x value is, in this case, 1 over our y is 0. Well, then that means we can't divide by 1 over 0, so that is undefined. Okay, so now let's talk about reference angles. Our reference angle is any angle, as I kind of like our terminal angles before, but our reference angle, if I were to put in any angles, they are all the angles that allows us to have the closest to the x-axis. So this is our reference angle per se. So if this entire angle was theta, our reference angle would also be this, right? If I drew a different one, if this is our theta, our reference angle would be that one. Let me do a different color. If I drew another one all the way on the outside, if our reference angle is all the way this one, theta, not our angle, original angle, our reference angle is this one, this small one right here. And as you can see, the pattern goes. Anything, our reference angles is always going to be the one that is closest to the x-axis. So let me erase all of this and let's do an example. By now you should be able to graph angles accordingly. So, but let's try a tricky one. Let's say theta equals 13.1 radians, right? So 13.1 radians. Well, it's not in pi like we like it, but we know we can always multiply everything by pi to figure out. If I did 2 times pi, like 2 pi or 360 degrees is 6.28 radians. 6.28, let me do some bigger numbers. 3,185 radians. That is still less than 13.1. But if I multiply that by 2, that is still less than 13.1. So if I did that, so 13.1, so that means if I went around twice, one and twice, so that a whole 4 pi, if I did a whole 4 pi, right, kind of like an ollie, if you're going to do some kind of cool skateboarding skills, that's a 12.56637 in terms of radians. Now we're getting close to our theta. So this angle looped around twice, like 2 circles. So I'm just going to find out what it actually is. So minus 12.6637. This gives me 0.5336. I'll use that. 0.5336. Let's try to see what that means. If I did pi divided by 2 here, this is 1.57. So I know my angle is somewhere here. It looped around twice, so it started here. It went once, twice, and ended up here, just like that. So that is my angle. My reference angle is going to be just this. It's going to be just that. So in this case, it is going to be just this one right here, this 0.55, because I stripped away the 2 circles, the 360 degrees, 360, or in this 720 degrees. So that is actually my reference angle. Let's do some more angle exercises, but now without having to use a calculator, right? So let's say we are given 855 degrees. 855 degrees. Well, first things first, I'm going to strip away some of the circles. I know one circle is 360. 2 circles, right? 2 loops is 720 degrees. So I can do 855 minus 720 degrees. That gives me a 135 degrees. Oh yeah, I can work with 135 degrees. So if I draw a quick picture here, 135 degree is over here, like so. My reference angle, and this was what allows me to deal with this, is okay, it needs what, 45 degrees? 45 degrees to get to 180. So my reference angle is 45 degrees. Like so. And so that, I know 45 degrees. That's a 1 root 2 right there. So now I can figure out my sine, cosine, and tangent of all that. So here my sine of theta is 1 over root 2. My cosine of theta is 1 over root 2. And my tangent of theta, but you got to be careful here. Right. My sine, hang on. I have to be careful because the cosine is my x. My x value is negative. Right? So this is actually negative 1. So my cosine is negative 1 over root 2. My tangent is 1 over negative 1, which is negative 1. We always have to be careful with our signs here, whether or not it's negative or positive. Let's do another one, but this time using radians. Okay, so here, if my angle is 11 pi over 6, let's do 11 pi over 6. Well, I don't know what that is. I know that 12 over 6 is 2 pi. So it's not quite 360 degrees, right? So I know it has to be somewhere here. 11 pi over 2 6. It only has a 6 left. Yeah, pi over 6. It only has a 6 left. So my reference angle here is pi over 6. This is pi over 6 will allow me to get to that. And pi over 6 is pi over 6 is 30 degrees. Yeah. Okay, so this is actually 30 degrees. And 30 degrees, I can do that. That's my special triangle. So this is my 30, 60, 90. And so this is 1, this is root 3, and this is 2. And I have to be careful because now my y-coordinate's negative, right? Because I'm going down 1. Negative 1 over root 3 to the positive. So now I got that. I can do my sine. My sine of theta is negative 1/2. My cosine of theta is root 3 over 2, and my tangent of theta is negative 1 over root 3. Like that.